Hey everybody, Dan here with Hardly Brief Tutorials. Today we're going to be looking at how we can use Raycast in our 2D games. We're going to look at using overlap, so overlap circle or overlap cube, and then we're going to look at shooting individual rays specifically to detect whether something's above us or below us. And then lastly, we're going to look at using Raycasts, multiple Raycasts, to create a much more detailed, higher resolution view of what's below us or above us. If that all sounds interesting, please stick around. Hit the subscribe button if you haven't done it already, and click the notification icon so you get notified when I release a new video. Also, the final script of this will be in the description below for you to download so you can take a look at it and use it for your own projects. Let's go ahead and get started. So to get started, we need to set up our scenes. I've already gone ahead and done that, but you need to set yours up. So the first thing I have is a player sprite. This can be anything. It can be a box. It doesn't have to be an actual person. Here I grabbed this sprite off of Google. I've attached a rigid body 2D as well as a box collider 2D. On the rigid body, I've restricted its rotation on the Z axis, and that's all I've done for that character. I've also have a script on here called player movement, which you'll add in just a moment. The other thing I have is a ground sprite. So I've created a sprite that will be in the description below to download, but basically it's just a brick sprite with a whole bunch of little bricks underneath of it. And then on top of that, or on that, I've added a collider, a box collider, and you can edit the size to match the size of what you want. So here I've just dragged it out so it stretches over all these different sprites. And then lastly, this is the most important, is you need a layer called ground. So you go up here, click add layer, and I've gone ahead and added test, and then click back on ground and then change it to test. You'll get a pop-up that says, do you want to change all the children to ground? You say yes, and then you're good to go. Once you've done all that, let's jump in and start coding. Okay, so to get started, you're going to need an empty script. I've called this one player movement because we're looking for whether or not our character is grounded or if something is above our head. And in that script, there's nothing. It's just an empty blank script for now. Okay, so to get started, you need a script. I created a player movement script. It's empty for now, and I've gone ahead and attached it to our player, as you can see in the inspector here on the right. And then you need to right-click on your player in the hierarchy and create an empty object. Here, I've called it ground check. Now, what we're going to use this transform is to actually cast or create a circle, and we're going to look for the ground in that circle. So what you want to do is double click on it, and in the inspector you want to center it around your character's feet. So I'm putting it in the center around my character's feet, and this will be a little bit more obvious once we actually write some code. And let's do that now. So let's go to player movement. I'm going to open that up in Unity, or excuse me, in Visual Code. And the first thing we're going to do is create a couple variables. The first one's going to be a public transform, and we're going to call this ground check transform. And this is going to be that game object that we just created. We want a public float called ground check radius. So this is going to be the radius of the circle that we're going to create. And we'll just set that to 0.5f for now. And lastly, we want a private variable called bool, and we're going to call it is grounded. And this is going to tell us if we're actually on the ground or not. And we're going to set that equal to false to start. Now, what we want to do is actually create the method or write the lines of code that can detect whether or not we're on the ground. So we're going to say void update. And in our update method, we're going to check for a collider. So we're going to say collider, collider 2D, and we're going to call this ground collider. We'll set this equal to physics 2D dot overlap circle. And overlap circle takes a few different things. The thing to get it to work, though, is a point in space, so the center of the circle, and then a radius. So for our point, we're going to pass in our ground check transform. Dot position. And then we're going to pass in our radius. So we'll put in our ground check radius. And there's one more important thing that we haven't done is the layer mask. And so we're going to actually call this ground layer mask. And this is a variable we have not created yet. So I'm going to highlight it, Control C to copy, come back up top, below the ground check radius, and we're going to say public layer mask, and then we'll call it ground layer mask, and we'll be able to assign what layer we want to detect collision on in the inspector. And the reason why we're assigning a layer is because Unity recommends, for best practice, that you limit the amount of collisions that are possible when you're casting and you're doing these overlaps. This way we can limit this cast specifically to the ground layer. We're only looking at colliders within the ground layer. So now that we have this information and we're actually creating our circle, we want to be able to detect or change our variable is grounded to true or false depending on where our character is. And we're going to do a shorthand way of doing this. So we're going to say is grounded is going to be equal to our ground collider. And if that's not null, then we're going to set to true. Or if it is null, meaning we didn't find anything, then we're probably in the air, and then we'll go ahead and set is grounded to false. Now, the last thing I want to do before we go into Unity and check this out is we want to actually draw this on screen. We want to be able to see what we're looking at. So we're going to use a void on draw gizmos, and we'll set our gizmo color. So we'll say gizmos color is going to be equal to color dot red, and then we're going to use gizmos dot draw wire sphere. So we'll actually draw a red wire sphere on our screen, and this just takes a position. So we'll say ground check transform, and I'm not sure why this is not showing up. Oh, that could be why. I misspelled ground. Hopefully you guys caught that. So ground check position, and then our radius will just be our ground check radius. So there we go. So let's go into Unity, and I'm actually going to make this bool public so that we can see it in the inspector to see if it's changing. Let's go into Unity, and hopefully it all works. So we're in Unity now. Let it reload. We have our player here. We're going to drag the transform ground check into the inspector, and right away you should see a red circle come up onto your game. And then we have a ground layer mask. We want to change that to ground, which we created at the very beginning when we set up our project. And then you see our bool. So I'm going to press play, and our character should fall. And we can see that our is grounded is true. If I go into the scene view and I pick our character up, you can see that it's not grounded when he's in the air. And as soon as he lands, we're grounded. And that's how you use an overlap collider, which is great for this case. And you see this a lot used on the forums and stuff, but there's other ways that we could detect ground, and that's what we're going to look at next. We're going to go and look at how we can do this a different way using a raycast, a line that shoots out below our feet. And to set that up, again, under our player, you're going to right click, create two empty objects. I've created one called left foot and then one called right foot, and they're actually opposite here on the screen, but it doesn't totally matter. Just center the objects underneath the player's foot and set them really where you want. Just know that we're going to shoot a line from that foot to detect the ground. And once you've done that, we can go back into our player movement script. So in our player movement script now, we can start working on the code. The first thing we need to do is actually get those transforms. So we're going to come up here and say public transform, and we're going to say left foot, and we'll do another public transform, and we'll say right foot. Now, in our update method, instead of casting a circle, we're actually going to go ahead and cast lines. And the way we do this is pretty simple. I'm going to move this down a bit. We're going to say Raycast hit 2D, right, because we're in 2D. And we're going to call this left foot hit. And we're going to set that equal to a physics 2D dot raycast. And this takes a bunch of different things. We have an origin, so where's this cast coming from? Well, this is going to come from our left foot. So we'll say left foot dot position. It takes a direction. We want to fire this down, so we'll say vector2 dot down. And then it takes a distance. How far do we want this ray to shoot? Well, we can create a variable to do that, and we're going to call this ray length. Lastly, it's going to take a layer mask, which we're going to pass in our ground layer mask again. So let's go ahead and add ray length to our public variables up top. Below our is grounded, we're going to say public float. and we'll call it ray length, and we'll set that equal to 0.5f. So we're going to shoot a unit length of 0.5 for our ray. And we need to set up our right foot one. So let's go ahead. I'm going to copy this whole thing, Control C, hit enter, paste, and we're going to change this from left to right foot, hit. We're going to pass in our right foot position. Again, vector 2 is down. We're shooting it downward. We're going to use the same ray length of 0.5, and we're going to use our ground layer mask. Now we need to write some code to look to see if we're actually on the ground like we did down here. So in this case, we need to have at least one foot on the ground to be grounded. So we can say if left foot hit dot collider does not equal null, or we'll say right foot hit dot collider does not equal null. If either of those are the case, then we're going to say is grounded is equal to true. Else is grounded is equal to false. So if both our feet are on the ground, then we're falling. If both our feet are on the ground, or with one of our feet is on the ground, then we are grounded, or if both are. I'm going to highlight this ground overlap circle and hit Control question mark to comment it out, and then we're going to go down to our on draw gizmos, and we're going to write some code so that we can actually see these rays casting. So above this, I'm going to say gizmos dot color. We're going to color these red or magenta, so we'll say color dot magenta, and then we're going to use the gizmos draw line method, and this takes a position. So we're going to say left foot dot position. It takes a length, which in this case is going to be, or excuse me, it takes another vector, which is where the line should end. So we're actually going to create a new vector 2, and we're going to say our x is going to be our left foot position dot x, and then we'll do our y is going to be left foot dot position dot y, and then we're going to minus, because we're going down, our ray length. I'm going to highlight this whole bit of code here again, and we're going to change left foot to right foot. Right foot and right foot. Okay, so this should be everything we need to get our left and right foot working. Let's Control S to save and go back into Unity and test what we've created. So nothing shows up on the screen until we go ahead and drag our left foot and right foot. So I'm going to click left foot, and you see it populates on the screen, and I'll put right foot. We can zoom in, and we can see here the lines that are shooting down, the magenta lines, and those are detecting whether or not we're on the ground on our left or right foot. I'm going to click play. We should see in the inspector we're grounded. I'm going to go back in our scene view and drag our character, and if you watch the is grounded, we're going to stay grounded even though half our foot is off. So let's go back into the game. You see that one of our feet is off the ground, but we're still considered grounded because of our other foot is still on the ground. If we slide even more so that collider that we did last time isn't on the ground, you can see that we're still grounded, right? So the red circle, that overlap circle that we were casting, is no longer touching. So this might be a case where you need to use both feet, and this raycast might be perfect for that. Now, if I drag our character back up and up, you see we're no longer grounded until we hit the ground. So that's one other way to use the on ground to detect whether or not you're on ground using 2 raycasts. The last thing that we're going to look at today is how can we detect what's above our head using what I'm calling a multi-ray cast. So basically we're going to shoot a bunch of rays out of our head and detect whether or not something is above our head. And in order for us to do that, the first thing you need to do is create 2 things underneath your player called left head and right head. They're empty game objects. So again, just right click, create empty, label one left head and right head, and then position them accordingly. So the left and to the right of the player around the head. Now, once you've done that, we can go back into our player movement script, and we're going to begin coding some things. So the first thing we need to do is get reference to those left and right heads. So you'll say public transform left head, and then you'll do public transform right head. Now, this is going to be a multicast array, And what that means is we're going to fire as many rays as we need for how detailed we need to get. So what we're going to do is call this ray resolution. So we're going to come down here and say public int ray resolution, and we'll set that equal to 5, but it can be whatever you want. And then lastly, we need a way to collect all the outcomes of these rays. So we're going to create a public bool array, so square brackets for an array, and we're going to call this hit outcomes. And we're going to use the awake method, the awake method to set the size of this array. So we're going to say void awake. We'll say hit outcomes is going to be equal to a new bool array of size ray resolution, right? So when we start this, we're going to have a bool array that's a size 5 because our ray resolution is 5. So how do we do this? It's pretty simple, and we're going to create it all in a new method. So we're going to say void, we'll call it multicast ray, and square brackets. It's not going to take any arguments or any methods. And the first thing we're going to do is create a starting point for where all of our rays are going to cast from. So we're going to say vector2 starting point, and we're going to set that equal to our left head dot position. So that transform that we place to the left of our character. So all of our rays are going to start from the left point and then move to the right. Now we need to find the distance between each of those rays. So we're going to say float x dist between rays, and we're going to set that equal to 0 to start, and then we're going to calculate it now. So we're going to say if ray resolution is -2 is less than or equal to 0. So this is like an off case where we have a very low ray resolution. In this case, you'd probably just want to shoot one ray, but in this case we'll shoot in this case we'll cover the condition. But generally, if you're going to shoot 1 or 2 rays, you should probably just do like what we did with the feet, hit the left foot and the right foot. But here we're going to say x distance between rays is going to be equal to the math f dot absolute, so ABS. This is the absolute value of our right head dot position dot x minus our left head dot position dot x. And I'm going to highlight this because we're going to use the same thing down below. So that's our first case. All other cases, what we want to do is say x distance between arrays, math dot absolute value, take the subtraction, and then divide all this by our ray resolution minus 1. And now we have the distance between our rays. You can output it in a debug statement if you want, so you can see what it's like. But now what we need to do is loop through all of our arrays that is in ray resolution and actually cast array. So we're going to say for int I is equal to 0, for I is less than our ray resolution, I++. Then we're going to say if I is equal to 0, so this is if it's the first ray, we're going to say our starting point dot x is going to be equal to our left head dot position dot x. Then we're going to do a else if. So now we're going to look at the last position. So we're going to say I is equal to ray resolution minus 1. So our last one, what do we want to do? Well, we're going to set our starting x position is going to be on our right side. So we'll say right head position dot x. Else, so for all other cases, so for all the rays in between, we're going to say starting point x is going to be equal to our left head dot position dot x plus parentheses I times the distance between arrays, and that should create all of the starting points for our arrays. Now we need to actually fire them, so we're going to say Raycast 2D, right? We've already done this. We're going to call it hit. We'll set it equal to our physics 2D dot Raycast. The position, right, our origin of this cast is going to be our starting point. Then we're going to fire it up because we're going to detect what's above our head. So we'll say vector2 dot up. Then we'll say ray length for how long they'll be. And lastly, our ground layer mask will be our mask. Now we need to actually check our hit outcomes. So we're going to say hit outcomes of I is going to be equal to our hit dot collider. We've also done this before. the shorthand if statement, is null. So if it's not null, then we're going to set our hit outcomes of I to true. If it is null, we'll set it equal to false. And lastly, we want to go ahead and draw, and that should be a colon, not a semicolon. We actually want to draw these rays. Now you can do this in onDraw gizmos, but we're going to do it right here with a debug.drawRay. Again, this takes a start. So where are we going to start this ray? This is going to be our starting point. And then where do we want to go? Well, we want to go up. So a direction of vector2.up. And this is going to be times our ray length. And we're going to give it a color. So we'll say color dot magenta. And that should be it. So hit outcomes is public, and we can actually, so we will be able to see whether or not we're hitting an object above our head. And then this will allow us to have a bunch of rays being fired from our head at one time. So in order to use this method, we're going to copy its name and we're going to paste it in our update method here. So it's just going to be constantly call the multicast array. So we're going to be constantly firing these arrays, or these rays, not arrays, excuse me. And let's go into Unity and test it out. So this is not going to work until we press play because we are deciding the size of our rays and setting our bool array to the size of that ray resolution. But as soon as we press play, we can see that it's not working. So let's go ahead and figure out what I did wrong. We have an error. Oh, I forgot to assign it in the inspector. So we'll go ahead and grab our left head and our right head. Press play. And you see we have the rays that are firing out of our head up top. Let's go to the scene view. And if I grab the left head, we can actually adjust it. So I'm just moving my left head. So if I want to get it lined up with this line here, I can. Grab the right one. We want to make sure it's lined up with that. Make sure it's good. And we still have our 5 arrays. Go back to the game mode. You can still see them there. And if we look at our player, you can see that they're all false, meaning that there's nothing above our head. I've gone ahead and created a ceiling piece. I'm going to turn it on. And you can see, so let me lift it up a bit so it's not pressing down on our character. But you can see here that all the rays are intersecting. And so if we go back to our player, you can see that all these values are true, meaning that our player does have something above its head. So if I click this and I move it, oh, wrong one. Let's click the whole thing. And I move it to the left. Right now, we're over 1. So it might not look like there's something above our head, but because of this extra ray, we do know. And if we click on our player, you can see that the last ray in our array is true, meaning that there is something indeed above our head. And so that's how you use a multicast array to detect what's above your head. You can use the same concept and put it on your feet so you can have a very detailed view of what's below you, or a detailed idea of what's below you. Or you can put it off to the left or right. All you need to do is change the direction that you are creating the rays and whether the direction you're firing, whether it be to the right or the left. Thank you for watching. Hopefully you guys enjoyed it. Please leave a like if you can. If you didn't like it, leave a dislike. Leave a comment down below. Let me know what you want to see next. I would also appreciate it if you guys hit the subscribe button and hit the notification icon. It definitely helps a lot. But until then, I'll talk to you guys next time.